Now we have come to the end of inverse of functions with this last example. Then the next thing we need to do is to look at another topic, limit of functions. You know, like I always say, if you watch the video and you have some questions, drop on the comment section. If you like the video, please give it a thumbs up. Also share it so that your friends will learn. And again, if there are certain things about the video that is not very clear to you, please let me know. I'll do another video, or I can explain to you directly if you reach out to me. Okay. So the next thing we want to learn is limits of functions. Limits of functions. To motivate this, let us take a look at what we know from the secondary school or from the high school, how to plot the graph or graphs of functions. If I give you y equal to 3x plus 1, and I ask you to plot the graph of the function between minus 4, minus 1 less than or equal to x less than or equal to 2. We remember very well that the first thing to do is to do a table of values where you have a thing like this, x, the y value. We are given the range of x from minus 1 to 2. So when x is minus 1, we need to know the value of y. When x takes 0, we need to know the value of y. When x takes 1, we need to know the value of y. And finally, when x takes 2, we also need to know the value of y. And so we start. When x is 1, this will give us 3 multiplied by negative 1, which is negative 3 plus 1, and we get negative 2. If x takes 0, this becomes 3 times 0 plus 1, which is 1. If x takes 1, we have 3 times 1 plus 1, this is 4. And then this will give us 7. So we'll be able to find the values of y corresponding to the given values of x. After this table of values, the next thing to do is to choose appropriate scale, and then we say, using this scale, when x is minus 1, and then we have y to be minus 2, and then we plot. So at the end of the day, we have such a graph, you know. Okay. The concept of limits of functions is we want to know what happens to the images of a given function f as the values of x approaches a certain element of the domain of that function. I don't know whether this is clear. So I give a function. I give a function f at x. Our goal is to see. Remember, what this means is I must say x comes from the domain of f, for instance, so that this will make sense. So we want to know what happens to the images of x as x tends to a certain value, say a. That means as x is approaching this value a, where will the values of f approach? Or what will it approach to? What number does it approach to? So if we're able to get the particular number that the images of f approaches to, as the values of x approaches the point a, then we say that that number which these images approaches to is the limit of this function as x approaches the value a. Now, here x must belong to the domain of f. The question is it necessarily the case that a must also belong to the value to the domain of f? And the answer is no. A may not belong to the domain of f, but we are saying as x approaches to the value A, what will this approach to? Consider the function f of x is x plus 1. We want to see what happens as x tends to, say, 2. Like we know, this is the number line. This is 2, for instance. I can approach 2 from the left hand side. I can also approach 2 from the right hand side. By the left hand side, I mean considering all the values less than 2, they are now going close to 2. Then consider right hand side, I'm looking at all the values greater than 2, and then I'm coming down and approaching 2 very closely. So that is what I mean by from the left and from the right. Okay. So let's try to make a table of values for this. So in that case, I have here x, I have x, and then I have f of x. I want to take a look at those that are smaller than 2. So I look at, say, 1. I look at 1.5, which is 3 over 2. I look at other values, say, very close, 1.999, this way. Then I look at 2. I consider 2.01, 2.00, okay, 0001, 2.01, say 2.5, and so on and so forth. So here I have 1.5. Let me maintain decimals. So let's see what is happening. At x equal 1, we're going to have 1 plus 1, which is 2. At x equal to 1.5, we're going to have 1.5 plus 1, which is 2.5. We can see the trend that these values are increasing. So at x equal 1.999, we're going to have 2.999 continues. At x equal 2 exactly, we have 2 plus 1, which is 3. Observe what is going on, that as the values of x are getting closer and closer to 2, the images of x at the point x, their images, they're increasing from 2 to 2.5, from 2.5 to 2.999, and then eventually we get 3. So they're getting closer to 3. Now, what happens if we now start from the right hand side? At x equal 2.5, what would be the value of f of x? This is going to give me 3. This is 2.5. This is going to give me 3.5. And this one, I'm going to get 3.01. This one is going to give me 3.001. So you see again that as we move far away from 2, and then we start coming close to 2, the images are getting closer and closer and closer to 3. So with this information, what we are seeing here is that whether we go from the left hand side of 2, as we begin getting closer and closer to 2, the values of f will be getting closer and closer to 3. If we start from 4, coming from right to 2 again, the images of this function f will be decreasing, getting closer and closer to 3. Therefore, we can conclude that this function f tends to 3 as x goes to 2. And that is what we say, and in that case we say rather, that the limit of this function as x approaches 2 is equal to 3. So this is the whole idea behind limit of a given function.